Yes, good morning, Astik and Macwill. Is the screen visible?
Yes, sir.
Yes,
Okay.
sir.
We'll continue with our APT. We studied all the statements, namely geometry statements, then motion statement, auxiliary statements, and post-processor statements. How to make use of these statements in APT program. APT program, the weightage will be 8 marks, 8 to 10 marks, either in the form of program or it can be descriptive also. Descriptive means explain APT statements, any APT statements. So it is understood that you have to explain the syntax, you have to give the example, at the same time you have to draw the sketch also. Like it will be asked explain go to or delta, hmm, or CL later. So it is expected that you have to give the syntax as well as you have to give the example, and if sketch is possible then you have to give the sketch also. So the last statement was in APT, that was fini. Just to recap, fini stands for finish, and that specifies the end of the program. So it has a dual purpose, that is reset and rewind, which is nothing but your M code in your normal G code and M code program. So fini is equivalent to your M30. And remember to write finish, then you lose marks. So you have to write fini only. So fini stands for finish. Whatever spelling is there, you have to mention that spelling only. Like coolant, there is no E. So COOL So the motion statements is from, then go to, and go DLTA. Go DLTA means it will go in feed. That is, uh, and it will be always in incremental, and that's why this is given in delta X, delta Y, and delta Z format. For example, this. Now, suppose if you want to go from this phase to this phase in feed, then you have to give DLT. If you want to go from this point to this point, that is, remember these dimensions are in inches. Let's have a look. So that 2 is nothing but 2 inch. 1 is nothing but 1 inch. Distance between the two holes is also 1 inch. So if you want to move from point P0 to P1, then you have to simply give go to. So go to will automatically take it as rapid movement. And if you want to go in feed, that is, if you want to do the drilling, then you have to give the command DLT. Hope this is clear. So these are first are P0, P1, P2. These are your geometry codes where you are defining points. All the values are in inches, that is 3 inches, 2.1 inch. Then from go to, that is your rapid movements. Then go DLTA, that is from 0, 0 to minus zero point 0.7. So it is going in feed. That means whenever you read this it is understood that you have to understand that some machining activity is going on. Some machining activity. Either it can be drilling, turning, or milling also. So go DLTA 0, comma 0, comma plus 0.7 plus you don't have to mention. It is understood. So from that it is going to point P2. Go to P2. So that movement will happen in rapid. So from here, go DLTA to go to P2, it will happen in rapid. And this is very important from examination point of view. Part program is not asked, then statements that it can be asked that explain what is the drive surface, what is part surface, and what is check surface. These are the three different type of surfaces. It will be for 3 marks, but then you need to explain with the sketch. If you are lucky, it can be for 6 marks. That is 2 marks. So in 2 marks, definitely sketch has to be there. Other motion statements are go left, go right, go up, go down. This was just a recap. This also we have seen. So in this case, the cutter is passed. Here also cutter is passed. So pass means it will pass the line L3. It will do external cutting. If you say 2, then internal cutting will happen. That is, the cutter will stop till the line L2. And if you say on, then the cutter will be on this, the center line of the cutter will be on line L2, L3, like that it is. So in the previous one, that is, in this case, everywhere it was passed. I have one more example here. See how the geometry is defined. So you have number of lines. First, of course, you have to define the points. If you define the points, then it becomes easy to define lines and to define the circles. So here you have L1, then L2, then L3, then L4, L5, and L6. And if you talk about circles, then you have only one arc, that is C1. So again here it is SP means from start point, RGT is nothing but the right, FWD is nothing but the forward, tan 2 is tangent to. You have to use these words only again and again. I am telling. These are called as the auxiliary statements, that is additional statements, which helps you to understand the program in better way. Like here, machine. You might have noticed that E is excluded. So which machine it is? It's a machine that is a drill machine, and they have given some number that is 1, 2, 3, 4, 5, 6. So this is drill machine 2. This is coolant. So coolant on. So in again in coolant you have different types of coolants. You have mist coolant and you have flood coolant. So simply coolant is nothing but only the oil. which has great capacity for the heat dissipation. Mist coolant is used for non-ferrous material like aluminum, copper, where there is a mixture of soluble oil plus water and it comes in the form of a spray. So it is always assisted by the compressed air. You can have only air also, like your spray, like your perfume spray, which keeps on coming continuously when you use mist coolant. Blood coolant is your normal and it is used popularly, blood coolant. Then you have pad rat, pad rat that is for the feed rate. You have spindle. hmm, Here it is spindle on, spindle 1250 means the spindle will rotate at the speed of 1250 revolutions per minute. This is counterclockwise. Then there is a provision for selecting the tool number and so on. Again, it allows you to use English words like call uh, from P0. So this is again motion statements. Here you are using now drill. You can use the word like depth also, but specified word only, not all the words, because these are called as the assembly codes. So whatever has the programmer has inbuilt the codes, that codes only can be used here. Here, this is what is your starting point or tool change position or parking position where the tool is changed. And remember, tool change should be away from the workpiece or it should be at a safer height because when the tool change is happening, it should not dash the component. Sorry. Again, all these dimensions are in inches. Remember, so this is 2 inches, 7 inches, and zero point 0.5. So x, y, and z. So zero point 0.5 is nothing but the height above the workpiece. This P1, P2, P3 is nothing but the points. So now this particular example, it is very easy. This line can be drawn, line L1 passing through P2 and P3. This arc can be drawn. Before that, you will have to specify the point P4. So you can simply say arc center is C1 is equal to P4 and you can mention the radius and the arc will be drawn. Generally, the cuttings we don't use the RPM, we use the cutting speed. So for MS and HSS tool, it is 25, and for MS and carbide, it is 100 meters per minute. Remember the unit, meters per minute. And since it is meters per minute, that's why in the formula V is equal to pi dn upon 1000, V divided by 1000, just to make the dimensions on left hand side and right hand side same. Because V is generally expressed in meters per second, so multiplied by 1000, so that gives you millimeter per second. And diameter is most of the times, or I can say always, it is given in millimeter and it is never expressed in meter. So again here, hmm, you can write like part number, but in a specific format. There is no space, there is no dot also. So the correct syntax and correct answer is important. You may be under impression that I have written so much where the marks are lost. The mistake, if you put a dot here, that's a mistake. So you lose half mark here. Yes, sir. Part 11, machine. If you write E, again you lose half mark. This is mill. Instead of milling, if you write milling, again you lose. This is CL print. CL print is clear previous data. Clear previous data. This is out tolerance. You have studied intolerance and out tolerance. You can write the comments here, but in actual programming, hmm, these correct comments are not required. But these comments are just for your understanding. The program is understand. Like here now, CL print means it prints out this cutter location data file, hmm, and it clears the previous points which are stored in buffer. So this is all you are defining your geometry statements first. If there are repeated holes, then you can go for macro. You can use macro. These are the motion statements, that is go right, go forward, go left. Termac here. Termac is nothing but termination of the macro. That is, you are calling the macro in the program by hash symbol, and then you are ending the macro by termac. That is termination of the macro. This pin is nothing but spindle. That is spindle RPM. This is what I had presented at the start, the beginning of the lecture, today's lecture. So these are taken from the university papers, these examples. So even if you study these two, three examples, and that is more than enough for APT program. And remember, do not try to convert these dimensions in millimeter. Just use as it is. So 110.5, once or twice the query had come. So what are these dimensions? So these dimensions are in inches. So this is your 0, 0, and this is your V1 is at 1 inch, 1 inch, and at a height of zero point 0.5 above the surface. Now remember here the Z0 is at the bottom, and you must show your origin and you must show your program 0 point. Origin and program 0 point can be same. I hope you are understanding this diagram. Here Z0, Z is equal to 0, that is at the bottom of the workpiece, and the thickness of the workpiece is half inch, that is 0.5 inch. So P0, this point has been defined in space. So 3D coordinates are given here. P0, where is your P0? That is here, 0, 0, and at a height of 1.1 from the bottom. So from the top, it will be at a height of 0.6. Then point P1, here you are not giving any motion statement. This is just the geometry statements. The program will start with geometry statements and that too with the point. You have to define the points first. Try to define as much as points so that you don't have to use intersection or tan this command. So if you are using points, you are defining of the lines, this lines or this line or this circle becomes very simple. But at the same time, don't do too much of the calculations. Try to use the data which is given in the drawing. So here now P0, that is start point 00, and it is zero point 0.6 inches above the top surface of the workpiece. P1 is a point and most, so initially this is at this point x0 y0, so the tool is here, tool is somewhere here, and then point P1 is 1 comma 1 0.5. So it is 0.5 means where it is, this point is P1 is here, 1 in x direction, 1 in y direction, and point 0.5 that is from the bottom. So this is my point P1. So the z level of all the points, so all these points, the z level is the top surface of the workpiece, that is this. Then you have point P2, that is this. All these points are located on this top surface, and that's why it is third coordinate is 0.5 in most of the points.
So why is
So
not the
P2
point
is
P naught on 0, comma 0 and comma 0? Like, oh,
0, comma 0. See, usually point P0 is the start point.
yes.
So start point will be above the surface. From here, this is usually the tool change position. So the tool change position should be away from the workpiece, because when the tool is changing or if you want to mount the tool, then you should have a space, so that your hand doesn't foul with the workpiece. So if it
Sunny,
is
but
0
P
comma
naught
0,
P naught is
so the 0,
above the
so 0,
workpiece.
sorry, the 0
P
is
naught
here in this case.
P naught is
P
above
naught
the
is here.
workpiece now. P naught is
Yeah,
above the workpiece. 1.1
yeah, P naught is
height.
above the workpiece.
Yes.
P naught is
So it is
above the workpiece.
so it is
And
away from the
your doubt is
workpiece.
why not 0 comma 0 comma 0.
Okay.
Yeah, usually the start point is always above the workpiece and suitably at a position or at a parking position, at a at a safe position.
Okay.
If, if it is 0 comma 0, then it will be here because your z is equal to 0. So that point x0 y0 is here, so it is here. From
नहीं
here,
बट सर अगर वो
when the
वर्कपीस में
uh,
कोई भी पॉइंट पे ऊपर होगा समझ लीजिए
listen,
एक्स पे
suppose listen, suppose if you use 0 comma 0 comma 0, so from this point when it is coming here rapidly from P0 to P1, that time it will dash the workpiece. So it is always safe that the cutter should come from here to here. That's it.
ओके
Okay.
यस
Then you have point P2, then you have point P3, all at point all at top surface. Then you have plane 1. So plane 1 is nothing but passing to the points P1, P2, P3. 3 points are enough. Then plane 2 is parallel to the plane 1, and at an offset of zero point 0.5. So the plane 2 is this, plane 1 is this at the top, and then so on. So that is P4, P5. Now look at the circle, that is C1. So a circle, that is this, the center is given by P4, and P4 is already defined. You have to make sure that P4 is already defined, and the radius is 0.85 inch. Similarly, now C2. So C2 is a circle, uh, center is P5, and make sure that P5 is already defined here, that is this, and then radius is 1 inch, and so on. Now these are the motion statements. The motion statements. So from P0, that is P0 was here and it was above the top surface. So go to go to L1 to plane 2 and on L5. So on L5 means here. Alright, go to L5 means it will come to this point. Plane 2, that is along this line, and you have to assume definitely that when you are doing this external milling, the workpiece is mounted above the table. So there is a gap between the table and the bottom of the workpiece. So you might have mounted this workpiece with the help of a fixtures. You have bolted from the bottom surface, so that you can do this external milling. This particular now program is for this contouring, external milling. So go right of L1 tangent to C1. So tangent to C1, that means it is this point. Then whenever there is a arc, you have to give this command, forward command. So go forward along C1 and tangent to L2. Tangent to L2. And since you already defined your RGT, that is right, so the cutter is on the right hand side. It is always preferred that you write the program the external contouring like this. Not that difficult. Then go forward L2, go forward along L2 and past L3. So past L3 means now the cutter will come here. Then this, you are traveling on the left hand side of the L3. So L3, then past L4. So past L4 means now the cutter will be above the line L4. Then go forward L4. L4 के आगे जाना है to, the cutter will come here now. Obviously here now go forward C2 and tangent to C2 and till L5. So the cutter will come here at the end of this block. Then go forward L5 and past L1. So the cutter will pass the line L1 and at the end of this the cutter will be here, and when you say go to P0, so P0 is your X0, Y0 and above. So now at this statement the cutter will come to X0, Y0 and 0 at a distance of 1.1 from the bottom surface, because your P0 is X0, Y0 and 1.1. Again, these are the university questions. So this is another example. Again, try to define the geometry by points. Since all these examples has been taken honestly by Brewer, there is a group automation CAD CAM by Brewer, and that is a British book. There all the dimensions are given in inches, so the same dimensions has been retained, and even in the examinations also most of the time the dimensions are kept in inches only. So this is your, now look at this now, P0 is point 0 minus 2 0. So that is this 0 minus 2 and 0. So now here Z0 is again at the bottom of the surface or of the table, and what we are going to do, we are going to do the external milling. See, this is what I was talking, that is called as the center line programming. This is called as the center line programming. Now let us see in this whether it is going like this or whether it is going like this. The direction is shown this way. When you have P0, P1, P2 all at Z0 and Z0 is on the table, then these are the two circles C1 and C2 which are defined by the point and the radius. Then you have lines, only two lines, so the entities in this component are two lines and two arcs. That's all. Two lines and two arcs. Here this circle is tangent. Here it is tangent, mm, and here it appears to be intersecting. Okay. Now the component, now motion statements are component motion statements are from P0. Right. It go to, so it goes rapidly. Go to L1. So go to L1 means it will touch this line. If you say on, so this center line will shift here, and if you say past, then the cutter will go beyond. So internal cutting will happen. So here the cutter is on plane 1 and go to L1 and C2. So it will take the intersection of this. Then go forward C1 and tangent to L2. So obviously the cutter is going like this and tangent to L2. So L2 is this. So in this example, it is actually a down cut. Then go forward C1 tangent to L2, then go forward of L2, then tangent to C2, then go forward, then C2 tangent to L1. So at the end of this, go forward C2 tangent to L1. The cutter will come, where it will come here, tangent to CT down here. That is third last statement. So I repeat again here. Go left L1 tangent to C1. Then go forward C1 tangent to L2. Then go forward L2. Then tangent to C2. Then go forward C2 and tangent to L1. Hmm. Now from here the cutter is coming to P0. That is this. Hmm. So actually you need to machine this also. You have to say go forward or go left L1 and past C1, and then you have to say go to P0. So in this program, purposely, hmm, machining of this is not done. That's an error here. This is just if you want to study little in depth. Earlier, when the weightage was more than 10 marks, 15 marks, or sometimes 20 marks, program used to be asked, and that used to be a compulsory question. Question number one, 20 marks question compulsory. So that compulsory question was either APT program or G code M code program. So that time the weightage was 20 marks. So this example is that particular, that is 20 marks, because this is little complex. So it used to range question number one, a full program of 20 marks or 14 plus 6, like that it was. But then the pattern was changed, and question number one was entirely on the entire syllabus, whole syllabus, either in the form of short note or, like that it was, or answer in brief. So it was not made compulsory. Now, so the same pattern is the program. If you are interested, you can study. Otherwise, you can skip. But if you are skipping, that means you have to do other things properly. Because APT program, then CNC lathe program, and CNC machining program. So that will be 30 marks, and you have options of 40 marks because the complete paper is of 120 marks. You have to do other things properly. So here again you have different lines. So L1, L2, L0. You can define line by L0 also. L0, L1, L2. You have your L0, L1, L2, L3, then L5, L6. So L0 is here. This is what is your L4 is. That is passing to the point. L4 is defined as passing point, that is 5 comma 6. So obviously you will have to define point first, P5, point 4 and 6. That is, this point has to be defined first. Point. See, now here what I want to tell you here, that let's take example of L1. So L1 is equal to line. Now here this point has been defined here itself. This point is not defined previously. So take a note of this. So that way also it is possible. You could have written here P5 is equal to point oblique 5 comma 1, and then you have said here L1 is equal to line P5. Other way, that P5, instead of defining here, you define it here itself. So that is the twist or change in this program. So here the point is defined in the line command itself. Like L1 is equal to line, and it is passing through point 5 comma 1. So that is your point 5 comma 1. The point P1 is 0 comma 0, that is this. P0 is minus 1, that is in both the direction, x as well as y.
L1 L2 का
And then
intersection.
L1, yeah.
L1
So
L2 का
L1 is now,
intersection.
yeah, even L2 also same. So now see now, hello, see,
Yes, sir.
understanding, no?
Yes, sir.
So now here L1 is line passing through point 5 comma 1. So where is your point 5 comma 1? That is this point, isn't it? Which is not defined. So this line is passing through this point 5 comma 1 on the left, and it is tangent to this C1. So similarly L2 also. So it is a line and passing through the point 7 comma 1. So 7 comma 1 is nothing but this point. From here to here, this distance is 7. So that way also you can define. And then these are the motion statements. These are the motion statements. Which you are already familiar. Again here, if you want to practice some more examples, you can go through this. So here this is P0, that is point 0 comma 0 comma 3. P1 is a point 1 comma 0. So L1 is a line passing through P1. Another way of defining the line, so slope 0. So it is L1 is passing through the point P1 and having slope 0. Then L2 is again line passing through point P1 and slope is 90. So this is what is your point P1 is at a distance of 1 inch. Generally, we take this as a program 0 point. Hmm. The program 0 point and start point can be different. Right. So now here, this point, that is point P1, is located at a distance of 1 and 0. So the line L2 is passing through the point, and L2 is passing through the point P1 and having slope 90 degree. These are the motion statements. So again, in this case, the down cut cutter is going from here, and remember to bring the cutter again to the starting point, and this is the starting point, and then to the tool change position, that is this. There are other part programming languages, but the most commonly used.
Sir,
Other,
hello.
yes,
Sir, can you show me that APT program for for the passage for the path of a circle वाला part, वो जो आपने बनाया था जिसमें कर्व है, उस पे आप एक बार दिखाएंगे प्रोसीजर कैसे है होता है?
this you are talking. Which one, Amit? You are talking about which? This program or कौन सा?
सर नहीं सर, इसके पहले वाले सर. हाँ सर ये.
This one?
हाँ सर, इसके बाद आप एक स्लाइड खाली करके रखिए, मैं देखता हूँ, फिर मैं खुद पूछता हूँ सर.
ये?
हाँ सर, वेट सर वेट.
हाँ, yes.
सर इसके बाद सर. 83, 83.
Yes,
हाँ,
this one.
yes, sir. Yeah, sir. Wait, just a minute. Huh?
So what doubt you have here?
Sir, I just wanted to see if there's something I saw. I thought there's something wrong. I just wanted to see if it is wrong or right. Just a minute.
Hold on. Anything is wrong here?
यस सर, ये जो
Yeah.
ये GORG है, GORGT सर, वो जो दे रहा है इसको कमांड दे रहा है टू ड्रॉ C1 टू L2, बट सर वो उसमें सर्कल L2 तो नहीं जा रहा, वो तो सिर्फ यहाँ तक जा रहा है ना, L1 तक जा रहा है, सो वो कैसे फॉर्म होगा, L1 क्यों नहीं है इसमें, वो पूछ रहा था बस।
कौन सा बोल रहे हैं? Which line you are talking about? First.
सर सेकेंड कमांड
Go,
GORGT C1, that is to draw
go,
C1 and it has to
go,
go to
go right.
yeah,
Go right of C1.
yeah, go
Okay, go
right of
right of C1,
हाँ,
C1 and to L2. That means it will go till here. Okay, and right of C1 and ऐसा right में जाएगा C1 का and till L2 ऐसे. And
सर
then next is look at the next. Go right of L2 again and past L3. मतलब cutter यहाँ पे आ जाएगा यहाँ पे.
ओके
I'll explain again. See, go right. So it is moving from this. Go right of C1 ऐसा. Okay, cutter is traveling like this. Go right of C1, right of C1 and कहाँ तक? Till L2. Till L2. So that
ओके
means till here. You will not get sharp corners here. You will get a radius. So the cutter will appear at the end of this second statement. And
राइट
then
राइट
go right of L2. That is, it will go like this in this direction and past L3. So at the end of the third line, the cutter will come here. ऐसा यहाँ पे आएगा इधर. And then it will go right of this now. Where it is this tangent to C2. So that means the cutter will travel till here. So at the end of the fourth line, tangent to C2 means it will come here, and then obviously forward. So forward is that
राइट
is along C2 and tangent to L4. So it will come here. Is it clear? Your doubt?
यस सर, I'm it's clear sir, I got it.
Clear, no? Okay.
Thank you sir.
Yeah. Most welcome. So this is just for the short note only. 2 marks. What are the different part programming languages? It is adapt, import, then you have expat, you have compact, then split and map. Uh, Normally APT is the popular language, but APT or CLSF is same and it is generated automatically. Moment your model is done, uh, then APT file or CLSF file is generated automatically. The purpose of this teaching APT that you should understand, you should be able to, read the APT file which is generated by the software. Even now, G codes and M codes are also generated automatically because you have softwares available like say Mastercam or Tapis, even in NX also. So there also G codes and M codes are generated automatically. Once you call the post processor, once you select the control, uh, you get a G code and M code set. But you should be able to read because you should be able to debug, like Amit was asking just now. So APT is done now. We will start the fresh chapter in the next lecture. Yeah. Now, if you have any doubt, please ask. If you have any doubts, you can ask. You can discuss. E codes, M codes, programming, APT programming. Important from your examination. Okay. Aditya Aditya Sawant is there. Aditya Punjabi is there. Aditya Kamble, Aditya Sawant.